Good morning, everybody. Today we are presenting laser technology and its applications in the German market. My name is Hans-Friedrich Breithaupt. I'm the managing director of FW Breithaupt & Sohn, which is the German distributor for laser technology instruments. And I want to introduce Mr. Reich. Just put one. This one?
Yep.
And here we go. Oh, it's not working. Just a moment. Quickly set up.
Is it?
So perhaps somebody
go.
is... Oh,
I've got it.
perfect. And I want to introduce Mr. Reich, product manager of LTI.
Thank you very much. My name is Derek Rash. I work for Laser Technology. I'm the professional measurement senior product manager. Today we're going to talk about laser technology, field measurements, measurement tools, mobile mapping solutions, and software integration, and practical applications. Laser technology, we've been in business for 25 years. We design, manufacture, and distribute laser rangefinders that measure speed, distance, and inclination. We designed a laser rangefinder that worked for NASA. We also work with Bushnell recreational rangefinders. And we were the first ones that made a laser rangefinder that interfaced with GPS devices. Basically the first handheld total station.
Yes, some short notice on FW Breithaupt & Sohn. We are a little older than laser technology. Yes, last year we turned 250 years old. Always the main topic of our company was angle measurement. And we are active in very, very different fields, which is a good fit to the range of products of LTI. And we are accompanying laser technology since 1997. And yeah, we will see the applications of the lasers later, and then we give you an insight into the business topics which are covered by the lasers of LTI.
So a little bit about laser measurements 101. There are two types of lasers. There's a phase laser and pulse laser. Phase laser typically needs a reflector, especially on longer distances. It's a more accurate instrument, but it's also cumbersome. As you can see here, more of the total station. Pulse laser is what laser technology specializes in, AKA reflectorless. You can get any measurement, you can get a measurement to almost any type of surface. Our devices are built in with you have a laser sensor and an inclinometer sensor. With those two sensors, we're able to measure your slope distance and inclination values to these objects. With that, we're able to calculate that vertical distance and horizontal distance to the object, all with one press of the button.
Yes, this leads us to the first application scope we want to show you today. It's construction. It's one of the main fields where lasers of LTI are used in Germany. And there are several reasons for that. So it's one thing is on the design side. It's a very robust, easy to use instrument. And the other thing which I want to draw attention to is that as you have a scope, you directly see where you are measuring and targeting at. And you don't have to look for a red dot like at other products in the market. And this gives you a great advantage in construction. If you have distances, let's say 40 to 80 meters, it's much safer to see what you're measuring.
Other things we developed inside these laser rangefinders, we're able to measure 2D slope. Now this is where you would be at a base of that slope, and you can take a measurement to the base and a measurement to the top, and we're able to calculate that inclination or that slope value, right, all on board. So with the laser sensor and the inclinometer sensor, everything is calculated on board here. Another thing we built inside the instrument is to acquire the correct measurement. We have modes called closest and farthest. This is where you're able to acquire the correct measurement. If you're looking for that close target, you put it in the closest mode, or if you're looking for that farthest or long range target, you put it in farthest mode, and you're able to acquire the correct measurement.
The second scope I want to show you is environmental services and forestry. What is always interesting to see is that 1/3 of Germany is covered with wood. So it's a great topic within the economy to, let's say, inventory or to use harvest harvest data for different purposes. And like Derek just showed us, there's the filter mode, which gives a great advantage in the use in the woods, because of if you have leaves and branches hanging through between your target and your measuring point, then you have the advantage that you can filter them out. And that was one of the reasons why the equipment of LTI was used in the third Bundeswaldinventur, which is one of the greatest inventory works in Germany. And one other field which is getting stronger and stronger is environmental services. And we just saw how easy it is to measure slope with the true pulse. And that's one of the main applications in environmental services. Quickly get data for slope, distance, and others, which we can see right away.
Another thing we built inside the laser rangefinders is we want to measure height or clearance values. This is a 3-point height routine. You take a measurement to the object, you're going to take a top angle, then a base angle, and with those values, we're able to calculate that height measurement. It's good for clearance values or to heights of trees.
That leads us to utilities and telecommunications, where clearance is, of course, one of the most important topics. Again, the filter mode is a great advantage because you can filter the cables easily and get the right measurement very, very easily. You can measure height of poles, you can measure position of poles and register them, and of course you can also determine sag of cables. And this whole range of different data you can gain with the true pulse has led to a process which we are following up, that more and more of the ultrasonic products with all their weaknesses, especially humidity and others, are replaced by laser technology lasers.
Now, I talked about the laser sensors that did distance and inclination, but the third value we want to put into these laser rangefinders is a compass sensor. We call this true vector compass technology. So now we can get, with this true vector compass technology, there's no pitch or roll limitations. You can move the instrument around any which way you want, and that azimuth accuracy is going to stay the same. By incorporating the compass sensor and the laser sensor and inclinometer sensor, now we're able to calculate X, Y, Z coordinates, all built into a small device, handheld, true pulse laser rangefinder. With that, adding that compass, we're able to measure span, or distance between two remote objects. I can take a measurement to my first object, then a measurement to the second object, and I can get the distance, or those values, calculated between those two remote objects. It's all done on board, pretty simple and quick, but you do need to have the compass built in so you can get that azimuth value between those two remote objects. I talked about measuring that slope with the 2D, the True Pulse 200, or a 2D slope. This is a 3D slope, where I measure a slope from a remote location. I don't have to be at the base of that slope. So my first measurement is going to be to the base, second measurement to the top, and I'm able to calculate that slope value, or the percentage of that grade of the slope.
The introduction of the compass technology together with the laser technology has opened up great possibilities to measure, for example, in mining. If you want to do your blast planning, it's possible to measure in 2D or 3D, cover your data, plan your blasting. And what is also very nice, a very, very nice feature, we will see a little later that there's a nice software going along with it to calculate volumes, which is also interesting in other fields. And we sold several systems to German mining associations, and they measure with the equipment of LTI since decades and are very satisfied with that.
Other applications we're able to do with the laser rangefinder that has the compass built in is perform laser GPS offsets. Now we interface with most or all GPS devices. So with the GPS device, you're going to occupy and get a GPS coordinate. With the laser rangefinder supplying the azimuth, slope distance, and inclination value, the software can now calculate a remote GPS coordinate. That's all done within the GIS software of your GPS data collector. You can also do remote positioning without GPS. This is where you need to have that occupied coordinate, or a known coordinate value. Again, with the values that the laser rangefinders give you, the software will be able to calculate that remote coordinate for you.
Yeah, that shows the great advantages in GIS GPS work if you combine your GIS GPS systems with a laser technology, because you simply don't have to walk at every point you want to measure. You can measure everything which you can see from the place you are standing at, and of course you can save a lot of time in collecting data, for example, for local registers of trees and advertising places and others. So the range of possibilities in using a laser technology rangefinder together with the GIS GPS system is unlimited. We just learned about the missing line, which is also a very, very nice feature to collect distances and slopes from a distance, especially if you don't get, perhaps because of private property or other reasons, you can't measure the place directly. You can go to a remote site and do it from there.
So the instruments we were talking about, the laser technology instruments, is called a True Pulse 200. This is the one that's measuring that distance and inclination value. It's a brand new instrument that we're releasing right now at the INTERGEO conference. It's our entry-level professional laser rangefinder. The accuracy of this instrument is plus or minus 1 meter. The True Pulse 200, it also measures that slope distance and inclination value. This has been a flagship product for us for several years now. This is one that's got serial interface or Bluetooth communication to download to that GIS software. A True Pulse 200X, again, measures that slope distance and inclination value. This is a new product we're releasing here at INTERGEO. It achieves the highest accuracy instrument in the True Pulse product family. We've got an LED display, which is new for us, so you can use it in any type of low light conditions. And this also has serial communication and Bluetooth. New in this instrument, we're able to talk to iOS devices. The True Pulse 360, that's the unit that measures distance, inclination, and has the compass built in. So this is the instrument you'd use for that GIS, GPS applications. As you can see here, we're compatible with a lot of different hardware and software devices, the Windows mobile devices, smartphones, the Android, and iOS, and all different types of GPS devices. You might even recognize some that are up here on this slide. Everything's about mobile solutions. The True Pulse is a laser rangefinder, but you have to have that mobile solution to tie everything into your application. So we've come up with apps. This LaserSoft Measure is an app that we designed that goes on iOS and Android that just captures the raw data coming from our True Pulse or laser rangefinders. We also interface with Esri's ArcPad software. We're able to calculate that GPS position and use the laser rangefinder's values to remotely capture that offset point. We've taken it a step further and designed an extension to go on top of ArcPad to fully utilize the laser rangefinder's capabilities, doing the missing line, the slopes, everything like that you can capture within ArcPad, utilizing the laser rangefinder. Continuing about those mobile apps and about software is called GeoJot. We worked with a third-party company and designed another software called GeoJot. It runs on iOS and Android devices, and this is where you can use the phone's GPS, get that location, and that software will calculate that remote position with the laser rangefinder's values.
Yes, I just want to draw attention to a small piece of software. If you have users who are not capable working with GIS GPS systems or other software systems, which we just learned about, then TP Control is a very simple, easy-to-use software to record data and print data and export data of the True Pulse. And you are also able, if you use it on your mobile device, to edit some information in the field and then easily transfer the information later and then be able to work with the True Pulse data in your office.
Just a recap of what we covered. We talked about field measurements, utilizing laser rangefinders, and the mobile mapping solutions. Dr. Breithaupt talked about all the different applications that you can use the laser rangefinder with or software solutions. If you want any demonstrations or more information about the laser rangefinders or the software solutions, you can stop by either one of our booths here in Hall 3 and get some demonstrations. Thank you guys very much. I appreciate it.
Thanks.